2 on the back of that, all right, that's page 7. Question 1, I've already done another video for today, so if you're really interested in that one, confused about that one, you can watch that video once I post it this afternoon. But I think maybe it's beneficial to get this one on video as well. They're very similar types of questions. So what they're asking you to do is just determine the best way for you to classify as quadrilateral. So right now we're going to plot 0, 6. So there's 3, 4, 5, 6. So there's point A. Point B is at 3, 3. D is at negative 3, 3. And C is at 0, negative 5.
What question is 2 on page 7? What did I do now? Oh, yeah, I thought this was on this.
This was from Thursday. All right, so when I connect these things, the hope is that we can see that visually, maybe we question whether that's a parallelogram or not. Okay. Hopefully we can visualize and understand that this is all one-to-one scale on the x and y axes, and kind of looking at that and saying, well, it doesn't look like a parallelogram, probably means that it's not a parallelogram. But that's not enough. We have to show the algebra that disproves this from being a parallelogram. Does that make sense? Okay. So just like showing algebra to prove something, we have to show algebra to disprove something is something. Okay. So if I say, let's just find a slope of AB. Slope of AB. So I'm going to take 6 minus 3. So take your y value, subtract them. Then 0 minus 3. So I get, what, 3 over negative 3, which gives me negative 1, right? All right. So if this ends up being a parallelogram, that slope right there would be negative 1. What would this slope right here have to be?
Negative 1.
Negative 1. So let's see that. Let's see if that holds true. So if I got slope of DC, I'm going to take my y's, 3 minus negative 5. And I'll take my x's, negative 3 minus 0. So what's 3 minus negative 5?
8.
8. And then I get negative 3 on the bottom. Is that equivalent to negative 1?
No.
Nope. Okay. So opposite sides are not parallel, so what's this mean?
It's not parallel.
Not a parallelogram. Okay. If you remember, hopefully you do, we've had this picture where we've got a polygon, and then a subgroup of that is quadrilaterals, a subgroup of that is parallelograms, and then subgroups of those are rhombus, rectangle, right?
Yes.
And they come together to make
Square.
square. Okay, so we all know that, right?
Yes.
So this thing we've just shown proof that it cannot be that, right?
Yes.
So can it be a rhombus?
No.
No, because rhombus is a
Parallelogram.
it's a type of parallelogram. Not a square, not a rectangle, right? So what's this thing going to default back to?
Quadrilateral.
Quadrilateral. Okay. Now we haven't talked about this yet, and this is kind of the task of tomorrow, is to talk about these two shapes: a kite and a trapezoid. Those are the other two types of quadrilaterals that you could develop that can differentiate just a four-sided figure. There's 3 categories of four-sided figures. Okay. Kites, parallelograms, trapezoids. Tomorrow we'll talk about what makes those. Okay. So that one there you're seeing is actually a kite. Okay. And it has to do, if we were to find distances, it has something to do with that distance right there and that distance right there. What would you say about those two distances?
They're perpendicular.
Distance.
Oh, they're the same.
They're the same. Those two. So those consecutive sides are the same. What would you say about these two consecutive sides? They're the same. Okay. But opposite sides are not parallel. So that's kind of the issue that we'll talk about with kites and how we define it. If you were to plot that one, did you guys get a picture of what that one looks like?
Yeah.
What's that look like?
Rhombus.
A rhombus? No. Trapezoid.
Stop. Okay.
Okay, so
All right.
that one will look like a trapezoid, and because if you go through the slopes of all four sides there, you find out that two slopes are the same, opposite slopes are the same of the top and the bottom, but the side slopes are different, so you only have one set of parallel sides, and it defaults it then to just a quadrilateral, but tomorrow we'll be able to classify it as a trapezoid. Okay, so when you can't show it's a parallelogram, it's quadrilateral, and that's all we say at this juncture. All right, so that being said, let's talk about the last question. If I can find. Okay, so this is question 16 from that assignment. The other examples kind of going through maybe one or two in every class period. We're only going to get through maybe one here, but they're all going to be on a video at some point. So if we only get 16, but you struggle with 15 and 14, they are on the video. You just got to kind of watch that video when I load it after school today, and get those points and be able to answer those questions. I deliberately made these, and actually I've already done this one on a video, so let's do, I think 17 is actually maybe one of the harder ones. I deliberately made these ordered pairs large so that you had trouble graphing them, okay, on graph paper. Because I want you guys to realize that as long as you're drawing an accurate picture in regards to respective locations, you're going to be okay. And what I mean by that is if I have A at negative 1620, as long as you put that in the second quadrant, you're going to be okay. Okay? So I'm not going to count over 16 units this way and 20 units that way. I'm going to go over, maybe negative 1620 is right there. Actually, let's move it in a little bit. So maybe that's negative 1620. Would you agree that B, which is at negative 1812, should be further to the left of A?
Oh, yeah.
And it shouldn't be as far up as A, right? Because 12 is smaller than 20. So I'm going to put B right there. B being at negative 1812. Now I'm going to find C, negative 10. Well, negative 10 should be to the right of A, right? And now C is 14, so maybe a little bit higher than B, right? A little bit higher than that? There, good?
Yeah.
All right, so C is negative 10, 14. Now D is negative 8.
A little bit in, but way higher.
But higher than A, right? So to the right of, what was it?
Higher than that.
To the right of C, right?
Yeah.
But higher than A. So there's D located at negative 822. So do you see that it's not imperative that everything is drawn exactly to scale? Now it doesn't look when I do this because I totally guess kind of where those things are, but they're in respective order. I mean, negative 18 is further to the left, and negative 16, negative 10, negative 8, right? So in regards to how they appear left to right and up and down, I've got them respectively ordered correctly with one another. But my scale is all jacked up, and it doesn't look like a parallelogram, right? But I should be able to go through some work here to prove that it is a parallelogram. So can I find the slope of AB? Yeah. And again, my picture is just here to organize my calculations, to organize the things that I'm finding and what information I've gained from those. If I find the slope of AB, so let's look at these 2 points, I'm going to subtract the y values, right? What's 20 minus 12? 8. 8. And now I'm going to subtract the x values, so negative 16. And someone needs to write this down. Negative 16 minus negative 18, right?
Yeah.
What's that give me?
2.
2. So we 8 over 2, which is
4.
4. Okay? Now it says, what's the slope of DC? Well, DC is going to be these two ordered pairs, right?
Yep.
So let's subtract the y values. What's 14 minus 22?
Negative 8.
Okay, 14 minus 22 is negative 8. Now let's go negative 10 minus negative 8. What's negative 10 minus negative 8?
Negative 2.
Negative 2. What's that reduced to?
4.
4. What's that? And this is the reason for my picture. I've just found 2 slopes, right? If I don't put this in my picture, I don't really gain what those slopes are telling me. We just figured out that AB and CD are the same slope, right? So it means those two sides are parallel, right? Now we go through and find slope of BC and AD in the same fashion. Okay, so BC using those two ordered pairs. So we're going to 12 minus 4. What's 12 minus 4? Sorry, 12 minus 14.
Negative
Negative 2. And now I'm going to go negative 18 minus negative 10. Negative 18 minus negative 10.
8. Negative 8.
Negative 8. So negative 2 over negative 8 gives me
1/4.
1/4. Okay. And then we'll find the slope of AD.
You said you didn't have any down.
Huh?
Down the camera.
So AD,
Try to.
20 minus 22. Negative 2, right? Negative 16 minus negative 8. Negative 8 again. So what's that reduced to?
1/4.
1/4. So now, again, why my picture is because now I can fill that information in, and now I know that shape is a what? It's a based off that information, it's a parallelogram. Okay. Looking at the other information in there, because it says parallelogram, but I have options. Could be a rectangle. What's it need to have for a rectangle?
Right angle.
A right angle. And how do I talk? Once I do slopes, how do I know if I've got a right angle?
If they're opposite reciprocal.
Opposite sign reciprocals. Are these two things
Yes.
opposite sign reciprocals?
Yes.
Are they?
No.
No, they're all positive slopes, aren't they?
That's true. That is
Okay,
true.
so this shape here is just a parallelogram because there are no right angles. And that's what I was asking when it says find the slope of AC and find the slope of BD. Find the slope of AC, which is that right there, right? So what's the slope of AC? 20 minus 14 would be,
What?
20 minus 14 is
6.
6. Negative 16 minus negative 10.
Yeah.
What's that give me? Negative 16 minus negative 10 is negative 6. Okay. So what's that slope then of that line right there? Negative 1. So AC slope is negative 1. Now I want BD slope. So BD slope is going to be found by those 2 points, right?
Yep.
Okay, so I'm going to go 22 minus 12. 22 minus 12 gives me 10 up top, right? And then I'm going to go negative 8 minus negative 18. What's that give me? 10 on the bottom. What's that reduced to? 1. Okay. If you multiply the two slopes above together, what do you get? Multiply those two together, you get?
Negative 1.
Negative 1. So when the product of two slopes is negative 1, what's that tell you about those two lines? Nope.
Perpendicular.
Perpendicular. Okay.
Yeah.
Remember, this is the definition of opposite sign reciprocals, right? The algebraic definition is that their slopes multiply together to give you negative 1. So, right now, we have a parallelogram in which, put a right angle right there, we have a parallelogram in which the diagonals are perpendicular. We have a property that should allow us to classify that a little bit better than just saying it's a parallelogram. What can I call it? If the diagonals are perpendicular of a parallelogram, what is that classified as? Obviously, it's not a parallelogram, so that's not an option, right? It's not that. So it's between those things.
Rhombus.
Rhombus. Okay. Now, what if I wanted to show it the square? What extra information would I need to show the square?
All 4 sides would be congruent.
Okay. All 4 sides congruent would work. So I got to find distances. Can I find diagonals congruent?
And 4 angles.
Okay. I can find 4 right angles.
It's not.
Okay, right angles would work because I've already shown it's a rhombus. So if I show a rhombus and a rectangle at the same time, so the right angles would be a rectangle. If I show those two things at the same time, then it would be a square, right? This is why I asked this. Now, I think you guys can do this part here on your own, okay? But this part down here, this is the reason why I asked. The shape that we just classified is not a square, right? It is purely a rhombus. And it says, what information would you know to say the shape is a square? What extra stuff I'm going to show? And those are all options. Show right angles. Show congruent sides, all that kind of stuff, right? But are those options here?
Yes. V.
All sides are parallel?
No.
Think about that. If all sides are parallel, then we have something like this. Not a shape, right?
Oh, wait, no.
Okay? So that's not an option. Diagonals are congruent. Is that enough to show that this thing is a square.
There's a star.
That's just because diagonals can run, that exists for rectangles, right? And if a rhombus is a rectangle, the rhombus has to be a square. So C is my option here. Okay? Diagonals bisect each other. That's just true for all parallelograms. Okay? A consecutive size parallel again doesn't make sense. Consecutive sides have to intersect. But what I'm hoping you see there is that as a student learning these properties, yes, you know, he said show a right angle, show one of the vertexes is a right angle, or show that four sides are congruent. Those are options, or are the options that I present you with? No, so you're the person that says, oh, I'm going to memorize or learn a couple of these properties because that's going to get me through stuff. It might get you through some things. But when I phrase a question like this, and I leave out those common things that you should know, and then hopefully most students would come across the conclusion of, and I word it this way, it forces you to learn that property, right? Okay? So, as you start preparing for your test on Friday, please learn your properties. If you do not know your properties, you will not be successful in that test. Okay? If you know your properties, you'll probably breeze through it in half hour, 35 minutes. Okay? And give a grade on it. If you don't know your properties, you're going to be swimming. Okay? This is starting the 5th week of this stuff. If you don't know that diagonals bisect each other and stuff like that, we have issues on what we're doing as a student in class. No homework, Steve. Yes?
Oh.